All right, let's look at theorem 2, triangle inequality. Right. So in triangle ABC, AB plus BC is always greater than AC. Right. So the sum of the lengths of any two sides is always larger than the length of this third side. Right. So let's prove that. Alright, so pick any triangle ABC. So we know that ABC are non-collinear. Alright, then we're going to construct an extra point D, right, such that, let's see, we're going to actually extend this CB this way, right, and then create a point called D, alright, and making sure that, let's see, the length, maybe I'll do this. Alright, then make sure that the length dB is equal to AB. Alright, so let's write that down. Alright, 2. Alright, we're going to construct point D on line BC, so along BC, with the following condition. So such that, alright, so the betweenness condition is DBC, so DBC, and also, alright, let's see, BD is equal to AB. Right, actually, I'm going to write it as DB is equal to AB. Right, so this is just a segment construction theorem, so I'm just going to say justified by construction theorem, right? Then I'm gonna create a triangle here. All right, so you can see that this is isosceles triangle. So 3, we can say that angle here is congruent to angle there. So we can say BAD angle BAD is congruent to angle BDA. Alright, this is by isosceles triangle theorem. Alright, so we have that. Alright, then we're going to look at, let's see, we're going to compare the angle CAD and CDA. Alright, so look at, let's see, 4. Alright, so let's look at the angle CAD. Measure of the angle CAD. Right, this is going to be equal to CAD is the sum of the angle, measure of the angle, CAB, and the measure of the angle, BAD. Right, so this is by guaranteed by A2. Right. Let's look at A2. All right, A2. Right. So if D is the interior of the angle ABC, all right. So you can see that the B is actually the interior of the angle CAD because betweenness condition is DBC. Right. So angle is split into two measures. Right. So that's by A2. All right, then you can see that since BAD, actually CAB is going to be positive, so this guy, any measure is positive, any measure of an angle is positive, so we know that the 5, if you drop that, measure of the angle, CAD, is strictly larger than measure of the angle BAD, right? So this is by A1, right? A1 said that the measure of the angle is strictly between 0 and 180, so it's going to be always positive, right? So we have that, right? Then we can combine line 3 and line 5 to get this 6, right? Measure of the angle CAD is greater than, right? Measure of the angle BAD is same as measure of the angle BDA. Right, you can write the BDA or CDA, same thing. I'm gonna write the CDA. Right, so we are combining line number 3 and the line number 5 to get that. All right, so we can see that the angle here, so angle here is larger than angle there, right? So we can use a scaling inequality. The side, which is DC, opposite from the larger angle, is going to be longer than the side, which is AC, opposite from the smaller angle. So 7, right, by scaling inequality, so we know that the DC is larger than, or actually, DC, which can be written as dB plus DC. So dB plus BC, because of the betweenness condition, is going to be longer than AC. Alright, so I'm using the betweenness condition 2, right, which gives you that. And this is inequality, scaling inequality. Right, scaling. Right, scaling inequality to get that. Alright, then since dB is equal to AB, so this is the conclusion we want to make. So therefore, by replacing dB by AB, we get AB plus BC is strictly larger than AC, right? So I'm combining line number 2 and line number 7 to make this conclusion, right? So this is the proof of a triangle inequality, and this could be any two sides. So the sum of the measures of any two sides is going to be always strictly larger than the measure of the third side. All right, that's it. I hope that this was clear.